So welcome to this third in the series of how to do exam questions videos. And I thought I would do this one today. It's a little bit of knowledge and mostly common sense, I think. You can decide for yourself whether you agree with me on that. But describe the action and purpose of a solar panel. Now, certainly for AQA, you need to be aware that what they mean by a solar panel is different to what they mean by a photovoltaic panel. So by solar panel, this is heating water using sunlight, using the infrared in sunlight specifically. So there's one of our 2 marks. And that water is used to heat the house, maybe, the building, or for washing self or things. So you need to draw a distinction between solar panel and photovoltaic panels. However, in this question, you would have realized that you needed to draw that distinction because it asks you what they do, and then it tells you what photovoltaics do. So clearly, this is not the answer to this. So in the UK, some householders have fitted modules containing photovoltaic cells on the roof of their houses. 4 modules are shown in the diagram. The electricity company pays the householder for the energy transferred. The maximum power is 1.4 times 10 to the 3 watts. And you're asked, how long does it take to transfer 168 kilojoules of energy? Well, you have, let's just take a look here and see how many marks there are for this. There are 3 marks for this, the time being in minutes. So the first thing you have to realize is that 168 kilojoules is 1.68 times 10 to the 5 joules, because 1 kilojoule is 1,000 joules. This is 168,000 joules, 1.6 times 10 to the 5. So we are delivering 1.68 times 10 to the 5 joules here, and we're doing that at 1.4 times 10 to the 3 joules per second, because 1 watt is 1 joule per second. So if you divide 1.68 by 1.4, I have my calculator handy there. So we've got 1.68 divided by 1.4. That is 1.2. 10 to the 5 divided by 10 to the 3 is 10 to the 2, because 10 to the 5 divided by 10 to the 2 is the same as 10 to the 5 minus 2, which is 10 to the 3. So we have 120 seconds. And 120 seconds, of course, is 2 minutes. So the answer here is 2 minutes. So there's a mark for realizing that 168 kilojoules is 168,000 joules. There's a mark for doing your calculation and getting 120 seconds. And there's a mark for converting that to minutes. So there's your 3 marks. Now we've got a simple meter reading exercise. So the modules are fitted on a roof. The householder gets an extra electricity meter to measure the amount of energy transferred by the photovoltaic cells. The diagram shows two readings of this electricity meter taken 3 months apart. The readings are in kilowatt hours. We end up with 194, we start with 44, and so the difference, of course, is 194 minus 44, which is 150 kilowatt hours. And we are told the electricity company will pay 40 pence for each kilowatt hour. We have 150 times 40. Well, 4 15s would be 60. So that would be 6,000 pence. So £60 would be the answer. The cost of the 4 modules is £6,000. Well, if you're going to make £60 in 3 months, I think we said, I think those readings were 3 months apart. There they are, 3 months apart. So £60 in 3 months means you'd get £6,000 in 300 months, because 6,000 is 100 times 60. And 300 months is 300 divided by 12 years. And that would be 4.5, I think. I tell a lie. 45 years, isn't it? $25 years. This is what happens when you try to do mental arithmetic when you're on YouTube. 25 years. State an assumption you've made in your calculation in part 3. Well, the assumption you're going to make is going to be around the amount of light arriving or the efficiency of the panel. So you could say things like shade. You could think about the panel becoming dirty. So you're assuming that there is no more shade, that the panel doesn't get dirty over that time. You're assuming that the amount of sunlight is constant, or rather has the same average. Is that 3-month period? You're assuming no maintenance. You're assuming no loss of efficiency. So there's lots of things you could say about that. But you only have to say one, a single assumption. You're assuming that the panels never fall into shade. You're assuming that the panels don't get dirty. You're assuming that the amount of sunlight is the same average as that 3-month period we calculated for. You're assuming that there is no maintenance you have to do and therefore pay for. You're assuming that the panels continue to produce electricity with the same efficiency. So a number of things you could say there. And then in the Northern Hemisphere, the module should always face south for the maximum transfer. What else would affect the transfer of energy? The time of day, the time of year, whether it is cloudy, weather, anything like that. So there you have it. You've got a little bit of knowledge, that careful distinction you have to make between solar panels and photovoltaics. You've got a little bit of applying your knowledge of powers of 10 and suffixes, knowing what a watt is, knowing what a kilojoule is, and a little bit of fiddling about with numbers with that. Hopefully a very simple calculation here, 150 times 40. Then a very simple calculation here where you take the cost of it and you divide by how much you're making every 3 months to work out how many years your panels will take to pay for themselves. And then really some common sense, I think. The obvious stuff that might affect the output of your panels. So hopefully that works for you.